Now let us come to the equation of ellipse. So first of all, let me define the definition of ellipse. Just like the case of parabola. Now if you take P a moving point and fix P is a moving point and S is a focus and this MM prime as a directrix or a fixed straight line. Now the locus traces or the path traces by this point P moving in such a way that it's distant from focus to it's distant from a fixed straight line or the directrix remains as a constant, where that constant is known as centricity E, where E must be less than 1 in the case of ellipse. So if E is less than 1, that means if PS by PM is always less than less than 1, then in that case it will describe an ellipse. So now let us derive the equation of the ellipse when the focus is given, the directrix is given, and eccentricity E less than 1 is given. So you draw this figure, take a point P here whose coordinate is xy. This is a moving point. And take S to be the focus and MM primed here to be the fixed straight line or the directrix. Now we consider E the eccentricity less than 1 for the case of ellipse. Now let us draw this one. Set S set perpendicular to MM prime. Now draw S set perpendicular to MM prime. Now take this set as the x-axis. You can extend this one to this side. Then we take this set as the x-axis and MM prime as the y-axis. Now let us consider for the time being this set as the origin. Now since set is origin, let us take the distance from set to S. Suppose the distance from set to S which lies in the x-axis as P, then the coordinate of S will be P0 because the y coordinate will be 0 on the x-axis. So let the coordinate of this focus be SP0. That is set S is equal to P. So the coordinate of S will be P0. Now by definition of an ellipse, PS by PM should be equal to E, where E is less than 1. So this implies that PS is equal to E times of PM. What is PM? It will be equal to PM will be same as N set. It is equal to E times of N set, where N is the foot of the perpendicular drop from this point P to the x-axis. It will be P times of N set. Now, if since on the x-axis, I've taken the coordinate of P as x, so the coordinate of N also will be x, but the y coordinate will be 0. So therefore, this will be equal to E times of x. So on this side, it will be EX. Now, what is PS? Using distant formula, the coordinate of P is this one, xy, and the coordinate of S is P0. So using distant formula, it will be x minus P the whole square plus y minus 0 the whole square is equal to E times of x. So on squaring this one both sides, you get x minus P the whole square plus y square is equal to E square x square. Simplify this one or expand this one, so you'll get x square minus twice xp plus p square plus y square is equal to E square x square. So this gives you the general equation of the ellipse. It is given by x square minus twice xp plus p square plus y square is equal to E square x square. Now, I can denote this one as equation 1. So, let us find out, because this point will cut the x-axis at 2 points. So, we'll cut the x-axis. So, let us find out the coordinate of that x-axis where this path traces by this one meet or cut the x-axis. So here too, from this given equation of this ellipse, you put y is equal to 0 because on the x-axis y will become 0. So you put y is equal to 0 in 1, then you will get this as x minus p is equal to E square x square, or x minus p is equal to, take the positive square root of, take the square root of this one will be plus or minus ex. So you'll get x is equal to p plus or minus ex, or x transfer to this side, you'll get x plus or minus ex is equal to p, or x into 1 plus or minus e is equal to p, and this implies that x is equal to p by 1 is 1 plus e, another one is p by 1 minus e. Since there are two values of x here, it means that the ellipse will cut the x-axis at 2 points. One is at A, say, and another one is at A prime. One is at this point A and another one is at A prime. So let us take this one, one at A and one at A prime. So from this one, it means that the ellipse cuts the x-axis not only at one point, like in the case of parabola, but it cut the x-axis at 2 points. One is at this point and another one is at this point here. And these 2 points where the x-axis, where the ellipse cut the x-axis will be called as the vertices of the ellipse. In the case of parabola, there is only one vertex, but here there will be 2 vertices, the point where the ellipse meets or cut the x-axis. Now next, let us calculate from here. What is set A? Set A, because the coordinate of this A here will be this one. It will be p by 1 plus e, so you will get p by 1 plus e here, 0, since it lies on the x-axis, so y coordinate will be 0. And the coordinate of A prime, which is another vertex of the parabola, will be p by 1 minus e, comma 0, where the y coordinate is again 0. Now since we have taken set to be the origin, so the distance from here to here, that is the x coordinate, will be p by 1 plus e. So you'll get set A is equal to p by 1 plus e. And set A prime, the distance from here again, from the origin to this point A prime here, will be p by 1 minus e. So set A prime will be p by 1 minus e. Now what is AA prime? AA prime, from the figure you can see that AA prime is equal to set A prime minus set A. So you know what is set A and what is set A prime. So you can substitute it there, and unsimplifying this one, you'll get twice PE divided by 1 minus E square. That is the distance between the 2 vertices of the ellipse will be twice PE by 1 minus E square. Next, you calculate what is CA. CA, that is this distance. CA will be equal to what? It will be it will be CA. Okay, here I've taken, okay, first let me take C to be the center. If C is taken to be the center, then in that case, CA will be half of this one. CA will be half of AA prime. So it will be equal to, substitute the value of this one, then 2 and 2 will be cancelled. You'll get PE by 1 minus E square, taking C to be the center of the ellipse. Now, what is C set? C set is equal to CA plus set A. We know what is CA, it is this one, and what is set A, it is P by 1 plus E. Substitute that one, then finally it will give you C set is equal to P by 1 minus E square. And then you can calculate what is CS. CS, that is this one. CS is equal to C set minus set S, or set S, or S set. But what is set S? That is distance from here to it is P. And what is C set? C set, we are getting it as P by 1 minus E square minus set S is equal to P. So on simplifying this one, you'll get it as E into PE by 1 minus E square. So the value of C set is this one. So from here, if you relate this set A, CA, CS and CS, you can see from this equation here, you'll get the value of CS is equal to E times of CA, and CA is equal to E times of C set. So this will give you the relation between CS and CA, and then CA and C set. Now next, we can take this one, if I take CS to be, if I take CA to be A, and then this will give you CS is equal to E times of CA, which means that CS is equal to E times of A. Okay, in the next lecture, I'll give you explain you the derivation of the standard equation of the ellipse. The one that I'm giving you now is the equation of the ellipse in general, not in standard form, but in general form when the focus, the directrix, and the eccentricity is given.